All right, so now you know how to find antiderivatives or indefinite integrals. And now we're going to learn how to use indefinite integrals to find definite integrals. All right, so if you recall from chapter 11, we had the fundamental theorem of calculus, which said that if we integrate a rate of change function from over an interval from a to b, we get the total change in the original function. Now, if this lowercase f of x is the rate of change function and capital F is the original function, then capital F is the antiderivative of this lowercase f of x. Okay, so we can evaluate the if we know how to take antiderivatives, we can evaluate the antiderivatives at the two limits of integration and find the difference in order to find the integral for a function. So let's see how that works. Let's take a look at the integral from 1 to 3 of 2x dx. Okay, this ought to be pretty easy, right? So the antiderivative of 2x, right? Just the antiderivative of 2x dx. We said before that it's x squared plus c. Okay, so the integral from 1 to 3 of 2x dx is equal to f of 3 minus, okay, this is capital F of 3 minus capital F of 1. The antiderivative at 3 minus the antiderivative at 1. All right, so we know the antiderivative is x squared plus c. So let's put in the values 3 and 1. So if capital F is x squared plus c, then we get 3 squared plus c. F of 3 is 3 squared plus c. Okay, and then we're going to subtract 1 squared plus c. All right, let's figure out what that is. So 3 squared is 9, then we have a plus c, and then we have 1 squared, which is just 1, and then we have to subtract everything in parentheses here, so this becomes a minus c. So notice that these c's cancel out, and I just get 8. Okay, so the integral from 1 to 3 of 2x is equal to 8. And this is always going to happen if you're taking the difference of the antiderivatives. These c's are going to cancel out. So now there's a shorthand notation that we can use. Shorthand notation that is commonly used. Oops, notation. Oops, Control Z. Notation I gotta spell. Okay, so we can just write this as the integral from 1 to 3 of 2x dx, and we can just write the antiderivative without the plus c. So we can just write x squared evaluated from 1 to 3. So that this square brackets means that we're evaluating the antiderivative between 1 and 3. Okay, and that's just the same thing. We're just going to do 3 squared minus 1 squared, and that's equal to 8. Okay, so that's kind of this is the more typical way that you see definite integrals written. All right, so in the next example, we've got a bunch of practice problems. All right, so I would recommend you go ahead and look at, try some of those problems in example 2, and I'll meet you in the next video.